In today's video, we are exploring how waves can be reflected when they encounter a boundary, and as part of this exploration, we will also cover how to accurately draw ray diagrams and understand the different kinds of reflection such as specular reflection and diffuse reflection. The first important point to understand is that not all waves are necessarily reflected when they meet a boundary between two different materials or mediums. In fact, when a wave reaches such a boundary, there are actually three possible outcomes that could occur depending on various factors. One possibility is that the wave may be absorbed by the material it hits, which means that the energy carried by the wave is transferred into the internal energy stores of the material, often resulting in a rise in temperature. Another possibility is that the wave could be transmitted, which means it continues traveling through the new material and exits the other side, and this process often involves refraction where the wave changes direction. The third and final option is that the wave may be reflected, meaning it bounces off the surface of the material and does not enter it at all, and this third situation is what we will be focusing on for the rest of the video. Whether a wave is absorbed, transmitted, or reflected depends on the properties of the wave, such as its wavelength as well as the characteristics of the materials on either side of the boundary. To represent reflection visually, we use something called ray diagrams, which are simplified scientific diagrams that illustrate the path of a wave, such as a light ray, as it interacts with the boundary. There is a key rule to keep in mind while drawing these diagrams, and that is the angle of incidence is always equal to the angle of reflection. To begin drawing a ray diagram, we first represent the boundary between the two materials. For instance, the top area might represent the air, and the area beneath the boundary might represent a mirror surface. So, in this case, the boundary line is essentially the surface of the mirror. We then draw an incoming ray of light which travels towards the mirror, and we add an arrow on this ray to indicate the direction it is moving. Before drawing the reflected ray, we must first draw something called the normal. The normal is a dashed line that is drawn at a right angle, which means it is perpendicular to the surface of the mirror, and it starts at the point where the incoming ray touches the boundary. This point is known as the point of incidence. The angle between the incoming ray and the normal is called the angle of incidence, and, for example, it might be 45 degrees. According to the rule we just discussed, the angle of reflection must also be 45 degrees, meaning we draw the reflected ray outwards at the same angle on the opposite side of the normal. This completes our ray diagram and gives a visual representation of how reflection works at a smooth surface. Now, let us talk about the two main types of reflection that can occur depending on the texture and smoothness of the reflecting surface. Some materials, such as mirrors, have extremely smooth and flat surfaces, which means that all the normal lines across the surface are aligned in the same direction. As a result, all incoming rays of light will be reflected in a consistent direction, creating a clear and sharp image. This type of reflection is known as specular reflection, and it is what allows you to see a sharp reflection of yourself when you look into a mirror. On the other hand, surfaces like paper may seem smooth from a distance, but when examined closely, they are actually rough and bumpy. These irregularities mean that the surface is not flat, and so the normals are pointing in different directions at each point on the surface. Even if incoming rays arrive in the same direction, they get reflected in many different directions because the angles of incidence, and therefore the angles of reflection, are measured relative to differently angled surfaces. This causes the reflected rays to scatter in all directions, and the result is that no clear image is formed. This scattered reflection is called diffuse reflection, and it explains why you cannot see a reflection in materials like paper or cloth. It is important to remember that in both types of reflection, whether specular or diffuse, the rule remains the same. The angle of incidence is always equal to the angle of reflection. The difference lies in the surface geometry, not in the behavior of the waves themselves. On rough surfaces, the changing direction of the normals leads to a variety of reflection directions, which causes the scattered appearance. That wraps up everything we wanted to explain in this video about how waves reflect and how this is represented with ray diagrams. We also discussed how smooth and rough surfaces cause different kinds of reflection. If you found this explanation helpful, please consider sharing it with your friends or telling your teachers about it, and we look forward to seeing you again in the next video.